Hello, welcome everyone. We will start shortly. While you're waiting, feel free to scan the QR code on your screen to learn a little bit more about MDClone and our Atoms platform. We are going to be going over the NLP Studio today, which is just one of the many features Atom users can find in this powerful self-service data environment. Users are able to explore dynamic data through high-functioning capabilities of the Atoms platform, which includes synthetic data, continuous data feeds, longitudinal data, unstructured data, flexible infrastructure, and third-party tool integration. We'll wait a few more minutes and we will begin. All right, it looks like we have a few more people joining, but let's go ahead and get started. So hello again, everyone. My name is Jenna Sarda, and I will be your host for today's coffee break. In just a moment, we will hear from Miriam Kaduri-Greenstein, a data and infrastructure product team leader and one of our very talented data engineers at MDClone. She will be sharing one of the many features of our Atoms platform, the NLP Studio. And with that, I'm going to hand it over to you, Miriam.
Hi, everyone, and thank you for joining. I'm Miriam. I'm a product team lead at MDClone, and today I'm going to talk about our NLP Studio and also to show the tool in action. I will start with a short introduction to NLP in the healthcare domain. Then I will demonstrate an example of a use case that was completed using our NLP Studio. In general, NLP stands for Natural Language Processing, which is the process of computer understanding human language. This technology is useful for a wide range of industries and applications, including voice assistants, social media classification, and many others. In terms of healthcare data, we know that most of the data is stored as free text. We're talking about 80% of our clinical data. Here we can see only a few of the examples of it, such as clinical notes or some other different reports. Now, this unstructured data cannot be analyzed. It's in high risk for holding private information and also cannot be synthesized since it's too unique. So many of the great things that can be done with clinical data are not relevant for most of the clinical data. NLP technologies for clinical data will usually be used for one of the following. It will be for classification, for extracting, or summarizing the relevant text. MDClone NLP Studio is about extract features out of free text. We want to take this large amount of unstructured data and transform it into structured data in order to make it available to users. There are a few things that are special in our solution, things that distinguish the MDClone NLP solution from other NLP solutions. The first one is that the NLP Studio is a generic tool. It can run on any free text data and is not limited only for text from a specific domain. Second is that in our product, the end user is the one that does the training process. So it's in his power to decide how specific the model should be. And he can do it based on his knowledge with his own data. And this end user, he doesn't need to have any NLP knowledge. He doesn't need to know machine learning or understand statistics. And he also doesn't need to have a huge amount of training set for achieving excellent results. With a simple process of tagging only a few of his documents, like we will see soon, he can get some effective models very fast. The training can be done using the NLP Studio, but the user can also choose to import his own model or use any other pre-trained NLP model. The platform can easily integrate with other models if needed. One more thing is the value for Adams users. Although the NLP Studio can stand on its own, it can be very useful for enriching the MDClone data lake. The MDClone Adams start with Ask, where you can ask any question using the data in the data lake. This data was loaded from structured sources. When we are using the NLP that gets unstructured input and returns structured output, the output can be loaded into the data lake in addition to the data that is already available. And now the MDClone Adams user can query all of it together. They can ask questions that involve data from structured databases together with data that was originally unstructured at all, without even caring about what was the original data source. And that gives us a much more powerful query engine. Now, let's take a look over a real use case example and understand how it can be completed using the NLP Studio. This use case is about prostate cancer and analyzing treatment choices and survival rates based on Gleason score. A few words about what is this Gleason score. It's a grading system for prostate cancer, grading that is assigned according to how similar the cells in the cancer tissue are to normal prostate tissue. If the cell look much like normal prostate tissue, a grade of 1 is assigned. When the cancer cells and their growth pattern looks very abnormal, a grade of 5 is assigned. And the grade of 2 through 4 have featured in between these extremes. At the two areas that make the most of the cancer are graded separately, the score will be a combination of two numbers. The first referring to the main cancer area, and the second referring to the second area. In the pictures over here, we can see example for some of the different Gleason scores. Taking a look of Gleason score 7, we can see it combines from 3 in the main area, which is this one over here, and 4 in the second area. This will be different and less severe than a score of 7 that is combined from 4 plus 3. And therefore, the entire grade is relevant. As we return to our use case, let's see what data do we need in order to complete this analysis. For defining a cohort, we need a prostate cancer diagnosis. These are already available as structured data, same as the medication data and the demographic data. When it comes to the Gleason data, even though there is a specific field in the clinical system, most of the physicians are not using it. So the best place to find this data is in the pathology reports. And those pathology reports contain a long text with also many of other data that is not relevant for this specific use case. And the Gleason score is hidden somewhere within this very long text. And there is not one document like this, there are many reports like this. And we will need to get the relevant Gleason score out of each one of them. Running an NLP model over this document will do this and extract for us in a structured way the relevant score with the relevant patient and date. So now let's go and see in action how the system is doing this. This is our NLP Studio, and we already loaded into it some pathology reports. I can see over here I have 101 documents. I also prepared a list of Gleason terms, which are all the different ways to present Gleason. We even have here the Hebrew word or the Arab word for Gleason. And I want to filter my documents and to have only the relevant documents for Gleason, so I can use my filters over here. And when I will turn my filter on, that is looking only for Gleason values, it will reduce my number of documents to 72, only my relevant documents. Now I'm looking at my first document in a token view. Tokens are the building blocks of the sentence. And I can see that some of the tokens are labeled. If the system recognizes a token as a number, a date, or a word from our dictionary, it will label it. I can also see that this JSON over here is highlighted because I filtered my document based on JSON, so the system will highlight what I'm looking for. Now, I'm going to start and teach my model the rules, how to extract JSON. And those rules are based on patterns in the text. And these patterns are built from a trigger and a match. A trigger is what I'm looking for, and the match is what I actually want to know about it. So in this case, my trigger will be the JSON, and match will be this 3 plus 4 equals 7. And note that I marked the label here and not the token itself, because I want to create a generic pattern that it will catch any numbers in this pattern and not just 3 plus 4 equals 7. And I want it to catch any JSON term and not just the specific JSON term, JSON store term. Now, when I'm clicking next, I created my first rule and the system moves to the next document. If it already recognized in the document a match based on the rule that it has, it will show it for validations. So I can see here I have 3 matches. The first one is JSON score with same pattern but different numbers. Second is using a different JSON term. And here in the third one, I can see that in the text, it relates to July 2000. If I will take a look over the specific document date over here, I can see it from 2006. So I don't want it in my results, this will relate to the document date. I will go back to my training mode and I will add another rule. The trigger and match will be the same as previous, but now I will also add a date to my pattern. I will teach my model to extract also a date if it exists. And now I'm clicking next and I move to the next document. I can see that I already have 2 rules in my model. If I will go back to the training, even though I got result from this document, I can see this star over here. This star means a spelling correction was done. I can see that the original word in the text was JSON with a Z, probably a typo, but the system knows to repair those mistakes and to extract values out of them too. I can continue overviewing my documents, and I can also jump directly to the document that has no match based on the rules that are already in the model. I can see over here that this is my JSON, and now it's a different pattern. So I will add another rule to cover another pattern on JSON. And then I can continue to the next document. I can continue clicking next or next unmatch through my document. But if I know already of a specific pattern that exists, I don't need to wait to meet it in my document. I have the option for manual document. Manual document will create a document only for training purposes. So I can put over here JSON value is 5. And now I created a kind of a fake document. There is no match here because there is no rule that matches this pattern. So I will add it. JSON is my trigger. The number, not the 5, the entire number is my match. And I will click next. And I created another rule. I have already 4 rules. And let's see another example using the manual document. Let's say the text is JSON is not 5. So based on the patterns and the rules that I have, the model will include this one. But I want it to be excluded because it's clear with the word not that I don't want it in my result. So I can go back to train mode, and I have an option for exclusion mode. And I can teach my model a new rule, say, same trigger and match, but if my match also include the word not, exclude it from the result. I will click next. I created another rule. I can see over here I have one exclusion rule, and just to see how it works, let's use some different numbers and terms. I can see this one was excluded, and in my final results, I will not see it. And I can continue reviewing my documents until I get to the point that there are no more rules to add. Here I can see it's not relevant, and I can go over until it's enough. Then I can go to review results. Review results give me a preview of how my results are going to look like, and I can see it with the entire text, so I can do a initial validation about the results. And if I think they are good enough, I will click submit, and the model will run and create my results. The results output will look like this. So we have a totally structured data set, including the patient ID, the date that was extracted from the model, the trigger, and the match. And I also have an option within the system to group the matches in different logical groups, and also this can be within my output. And now, getting back to our use case, after using the NLP model for extracting also the Gleason score as structured data, I have now a structured data set of all the data that I need for this use case, and I can start working on it. So this is it for the demonstration. Thank you for your time. And if you have any questions, you are welcome to put them in the chat, and I will be happy to answer.
Okay, hi. And I see we have here one question. So the question is how NLP can enrich oncology real-world data. And oncology is actually a great example because it's a clinical domain that many of its data is saved as free text. We have gene markers and DNM and PSA, and all of this mostly will find in some clinical reports. And using the NLP to extract this data and make it in a structured way. So we combine it with other data that we had to any research or analysis need that we have is really relevant for not only for oncology clinical domain, but this is a really great example of a clinical domain that has a lot of free text data.
Awesome, thank you. All right, we have another question here. If I want to see other information from medical records, such as lab results, will I be able to see that next to the NLP results?
Well, like I mentioned, the NLP can just be a standalone solution and give you the specific results that you asked for from your free text. But if you're using the entire MDClone Adams platform that contains the lab results, so you can actually now ask the MDClone Ask platform to give you lab results together with your PSA results or whatever you extracted from your document, and you will get one output file that contains all of this together. It will just be placed in the correct place in the patient timeline and will behave like any other data that you have from structured databases. So the answer is yes.
Perfect. Awesome. We have another question here, and it says, can you view the entire note in order to validate the rule is working as expected?
Yeah, so also here's the answer is yes, and I will maybe share my screen for that. Okay, great. So we can see that during the training process, we have also a validation process. And when I'm going between documents, I see the entire document. In this case, it's not a very long document, but I can have here a much longer text, and it will show me what was recognized by the model based on the rules that I have so far. So actually, I'm training my model and validating the training at the same time. And I can see, like we saw in the example of the data, that the first validation, it was missing. So we go back to training, added a new rule, and then again, looked at the document and see that it was cached. So yes.
Great. I think we have time for one more question here. So is there any sort of ongoing quality review measurement on the rules to account for drift in text format over time?
So I hope I understand it correctly. Validation should be done like validation in models. So you need to have kind of tag that data in order to validate it. Usually our way to validate is through a sample of the document, and like I said, can be done also during the process of the training itself, but also afterwards when you get the results, we have different mechanisms for validating. And if the model is running during time, and it can run during time, and we can't update the document, load new documents into the same model so we can enrich the results that we got already. So yeah, we will need to validate it during time.
Awesome. I just want to say thank you to everyone that was able to join us today. We will get to all your questions. If we were not able to get to them live, we will make sure that we're responding to you so your questions are answered. If you do have any other questions that you weren't able to ask today, please feel free to reach out to us. Our website is MDClone.com, and you can scan the QR code there to learn a little bit more about our Atoms platform. Thanks for joining us today, everyone.